Welcome to today's lesson. Today's lesson is on rational expressions. We've been looking at quadratics and things like that as far as factoring goes, and then we've been looking at polynomials in general. Today we're going to do polynomials that are going to be put in fraction form, and we're going to add, subtract, and multiply and divide those rational expressions. So basically, we're going to take a polynomial and put it in a numerator and a denominator. And that's what makes a rational expression. Obviously, you see the term ratio there in the term in the word rational, and ratio obviously means fractions. So we're going to write a polynomial divided by a polynomial. Now, recall that when we talk about fractions, it has to be in simplest form, numerator and denominator. We have to divide out common factors. We may have to factor polynomials, so that's the key to the success to simplifying rational expressions, is to be able to factor the numerator and denominator. And then we also have to make sure that we factor it completely to simplify. So this first one, simplifying this, well, obviously the denominator is going to be a GCF, and the numerator would simply be a double bubble problem here. This sign tells us negative, positive. This sign tells us the bigger number is going to be positive. What times what gives you 12 subtracts to 4. And I believe that's going to be 6 and 2. Now, here's where we get into simplifying rationals. The x minus 2's will cancel. Therefore, your answer then is simply x plus 6 all over 3. So not too bad. I believe you did this last year. Here's another one. If you recognize the numerator as the difference of squares, you can factor it. And the denominator will be a double bubble. And since this sign's negative, we know they're going to be different. And this is positive, so the 2 is going to go there because 2 minus 1 is 1. And again, we can cancel, and we end up with x plus 1 over x plus 2. So this equals that. Okay, and obviously pause it anytime you need a little more time to digest what we're doing. Now, to multiply rationals, we do the same thing. We have to factor. Well, this top one, 2x squared plus x minus 6, is going to be a split the middle term problem. So I'm going to split the middle term. A times c got to add up to b, so this is going to be negative 12, has to add up to 1. I think that would be 4 times negative 3, wouldn't it? So 2x squared plus x minus 6 would break down to 2x squared plus 4x minus 3x minus 6. And then we work our magic, take out a 2x. We're left with x plus 2. Divide, you get negative 3. So the numerator of the first fraction would be 2x minus 3 times x plus 2 over, I believe the bottom would be double bubble. What is it, x plus 5, x minus 1 times, now this numerator, we can take out an x and we're left with that. So we know we're going to have a factor of x, but I believe this will factor as well. It will, I think it's x minus 2 and x minus 1 in it. So we can write that factor down. And then the denominator down here, we can take out a 2x, and we're left with 2x minus 3, it looks like. And now we can take that and simplify. So x and x cancel. x minus 1 and x minus 1 cancel. And, oh no. Did we screw up? No, I don't think so. 4x squared, we can take 2x out. We're left with 2x minus 3. Let's see. Oh, there's 2x minus 3. Oh, I forgot a 2, didn't I? Right there. There we go. Thought I may have messed up. So there's 2x minus 3's cancel out. So then what we're left with is x plus 2, x minus 2 in the numerator, and x plus 5, 2 times x plus 5 in the denominator. Now don't work that out. You are done right there. That's simplified. So that's multiplying rational expressions. Now let's divide. Well, if you recall, when we divide, we multiply by the reciprocal. So all we're going to do is flip those. So if you factor the numerator here, we would have double bubble, let's see, x minus 7 over x plus 7, x minus 7, times x plus 7 would go on top, and then we would factor GCF out of 3x minus 21, and now we start canceling. Those two cancel, those two cancel. We're left with 1 over 3, because those are all 1s. So 1/3. So all of this becomes 1/3. Pretty awesome. So that's how we divide rationals. Let's do another one. So we have, let's see, x minus 4 is not going to change. This is the difference of squares. Oops, what's wrong? X minus 2, x plus 2. Instead of divided by, we're going to flip this. So I'm going to take this one. That looks like it's going to be a plus and minus. So minus 4 plus 1, I believe. And this is going to go in the numerator. X plus 2, x plus 3. And then work your magic. So those cancel, and that's it. So the answer then would be x plus 3 over x minus 2 times x plus 1. Okay, now simplifying complex fractions. Now this is going to take a little more work for us here. So we're dividing again, right? That's all we're doing here is taking a fraction and dividing it by another fraction. And if you recall, that means we're going to multiply by the reciprocal, which is like that. So I just wrote this right here, divided by this. That's what I did in the first step. And then step 2, we have to multiply by the reciprocal. We just flip the second fraction. And now we can start simplifying. Well, if we have x plus 1 squared and x plus 1 cubed, that means we can take out 2 of those, and so we're just left with x plus 1. And then x goes into x squared one time, so you have an x left. So it's just x times x plus 1. So that's a 1. And that's a 1. So it's x times x plus 1. Now on the second part, the first thing we have to do is get a common denominator in the numerator and denominator. So in the numerator, we're going to go ahead and find a common denominator. Sorry about this. It's going to be x and x. Ignore the phone for now. It's Mrs. Coffee, so I'll get back to her. So it's x minus 1 then. So we got to multiply this by x minus 1 over x minus 1, correct? So it's x minus 1 minus 1 over x minus 1. So now we can clean this up a little bit. That's going to be x minus 2 over x minus 1. Now we can go ahead and multiply by the reciprocal if you choose. It's probably a little easier. Now, nothing simplifies, does it? So that's it. There's your answer. 2 minus 3x times x minus 1 over x times x minus 2. Unless I did something wrong here, it doesn't look like we're going to get anything to simplify. I think that's it. Okay. Adding and subtracting rational expressions using the least common denominator method. Okay. Well, that is also something that we're going to have a skill using. You'll notice that we have different denominators. If there's nothing in common, like I can't factor this or this, then you simply just cross multiply it. So I have to multiply the left side by 3x plus 4 over 3x plus 4. Whoops, got to subtract. And then I got to multiply the right side by x minus 3 times x minus 3. So that gives us a common denominator that we can just write down here. And then in the numerator, we would have that. Now what we have to see is, if we expand this thing, will it factor? So 3x squared plus 4x minus 2x minus 3 over all this business down here. Well, that would be 3x squared plus 4x, nope, plus 2x, right? Plus 2x minus 3 all over 3x plus 4 over x minus 3. I don't think this will factor. Negative 9, have to add up to positive 2. Nope, that's impossible. So that will not simplify. We've done our job. That's it. Now this next one, though, is unique, is interesting, because we can go ahead and factor this out. So we wouldn't want to have to multiply everything by each of those terms. So the common denominator here, you can probably guess, is going to be x, x plus 1, and x minus 1, because that gets all of our terms. So now what is the 3 missing? Well, it's missing x, and it's missing x plus 1. What is the 2 missing? X plus 1 and x minus 1. And what is the x plus 3 missing? It is missing x. So if we expand this, oops, oh, I don't know if I want to expand that. Let's see. Let's not distribute the 2 yet. Well, that would be x squared minus 1, wouldn't it? These two. And then we have, I can't read my writing, x plus x squared plus 3x all over this. I'm not going to rewrite it. So 3x squared plus 3x minus 2x squared plus 2 plus x squared plus 3x. Still working on the denominator or numerator here. So I believe 3x squared, there's 1x squared. Now there's 2x squared plus 6x plus 2 over all this garbage. Okay, now a 2 will come out, but I don't believe we can get that to factor to simplify anymore. This will not factor, so you're done. Whew, that's a lot of work. That's a lot of work. So you might want to replay that and see how we did that. The last one here, again, we're looking for common denominators, but we probably should factor these first. So this is x plus 1, x plus 1, x minus 1. Now we have two of them over here, but we don't have it over here, so we need an x plus 1, and that's it on this side, isn't it? Times 1, minus 2, I believe it's x minus 1 is all that's left, correct? So we have x plus 1 quantity squared times x minus 1. To simplify, so that'd be x plus 1 minus 2x minus 2 all over x plus 1 quantity squared times x minus 1. Let's see what this simplifies to. Now, in a perfect world, I think this is going to work nice. That's negative x minus 1. If we take out a negative 1, that would be x plus 1, wouldn't it? Looky there. One of those x plus 1 is going to graduate and get out of there. So we have x plus 1 and x minus 1. So technically, did we need that x plus 1? Well, let's see if that'll work. So let's just use x plus 1, x minus 1, and see if we can get the same answer. No, we can't. It won't work. But it did work out that we could get it to simplify. So pretty cool stuff. All right, I believe you will have a web assignment over this. Take your time, make sure you understand it. I think most of this you did at the end of the school year last year.